in step 5, we're finally ready to take our samples. Now I've outlined a couple of the examples we've been working through here. So in the blue here, we have the chopstick example where, again, just to refresh our memory, we set up the null hypothesis with the assumption that the mean along our production line has been 10 centimeters. Because it was a production line, and we might have some feel as to the standard deviation, we've said we know that population standard deviation is 0.1. We said, I believe this is true, and if I've changed it, we're going to go with this, but the alpha we've set as a 0.05, which then when we take all that together into step 4, we set a decision rule of 1.96 or negative 1.96. So a two-sided direction. Because our null hypothesis is an equal, we are concerned about evidence in either direction. So a two-sided situation, and so that brings up the familiar 1.96 z value. So we're ready to move forward with that. Briefly, in the red here, we'll approach this after, and this is that, maybe a politician making a claim about the average income in a community is at least 52,000. And so here, because we're using terminology like at least, that's incorporating one side of the distribution as to always being supportive of the null, and so we have a single-sided test that we're going to run. We also said that we don't know the standard deviation of the population, so that leads us to a t statistic. And because of the because we're going to use a t statistic, we had to already say what our n was going to be, and so we said we're going to take a sample of 25 individuals, and so that lets us again find a critical value. Our cutoff line is 1.711, but in this case only negative 1.711, so it's a single-sided test. And so now we are ready to take the sample in either of these cases. We have the value that if our statistic falls outside of those into the rejection region, we're ready to reject our null. So let's take a look at a hypothetical sample. And so let's say we run, we're running the production line, and we take a sample of, I don't know if I said previously what would it be, but let's say we're going to sample 100 chopsticks. I guess we'd have to define if that's a single, let's call those single chopsticks, I think. I guess you could do pairs. So we're going to take a sample of 100, so our n is 100. Good, let's go with that. So n is equal to 100. That's going to be in the wrong spot. Still in the wrong spot. So once we take the sample, we will get what? We're going to get a sample mean. This is going to produce a sample mean. And let's say, for instance, it returns 9.985. Okay, and to kind of the naked eye, that looks very similar to 10. In fact, we maybe not even be able to discern that difference. But let's see if that is in fact enough evidence to reject the null that they average 10 centimeters. So because we've done all this work in steps 1 through 4, step 5 does not involve a whole lot of effort. We simply are going to calculate the z-score that we find in this sample. So z, remember, is x bar minus mu, and then we have sigma over the square root of n. So let's plug in those values. We just found 9.985. We're going to compare that to 10. We have a standard deviation of 0.1, and the sample size, what did we say, 100. Okay, and so again, what we've basically found is we found a value, 9.985, so this is 10, and we found 9.985, and what we're trying to find out is where along the distribution that falls. And is that going to fall into the rejection region? So let's finish crunching this. This gives us a z value of, that's negative 0.015. And what do we get down the bottom? That's 0.1 over 10. So negative 0.015 over 0.01. And we get a z-score of 1.5. Negative. I'll drop the negative there. So we get a z-score of negative 1.5. Okay, so it is 1.5 standard deviations below the mean. So that is, of course, not in our rejection region. So remember, our rejection region was 1.96, or a critical value was 1.96. So values, below, less than or equal to negative 1.96, you could maybe write it down this way if that's more interpretable. So if we were to find a z-score either below negative 1.96, below or equal to, or greater than or equal to 1.96, we would reject. In this case, we didn't. So we don't have enough evidence to shut down the production process. We haven't found enough evidence to reject the null hypothesis. Now, perhaps the next day we run a similar sample. This time, let's just walk through another example of taking a new sample. So again, we're going to sample 100. And this time we come up with, let's say we get 10.03. Okay, so again, very, very close to 10. We probably can't see it visually, but let's run that through our z-test. So this is the new x-bar, and we'll call that x-bar 2, the second sample for the second day. We get z, so it is then 10.03 minus 10 over, still 0.1, and we did another 100 sample. And so what are we left with? We get 0.03 over 0.01. I'm sorry, I lost a, oh no, we have positive. And that gives us a z-score of 3. So in this case, we are in the rejection region. So we have found a z-value over here beyond our critical value of 1.96. We would reject the null and then go with the alternative. Okay, so now we have reason to believe that the mean is not in fact 10 centimeters. So we might, in this case, that might be reason to shut down production and just verify that everything's going correctly into plan with our process. Okay, let's walk through it again. I thought I had something on the sheet there. Okay, let me grab this and we can go over and do this again. So let's just walk through one more time with, I guess we can move that over here. All right, so this time we are working with the t-statistic here because we don't know the population standard deviation. So when we take a sample, we're going to need to pay close attention to not only the sample mean, but also the sample standard deviation. So we run a sample of 25, right? That's what we decided beforehand that we were going to do. Let's take a sample and let's say we find an x-bar of 49,000. Again, this is less than 52,000. Before we crunch this, what if we would have found 59,000? We could, of course, calculate the z-score, but we can also notice that this is going to produce, sorry, we don't calculate a z-score, we calculate the t-score, but we can notice off the bat that this is going to be a positive t-score, and so because our critical value is a negative only, it's only a one-sided test here, of course this 59,000 sample is not going to reject the null. So let's look at the more interesting case where this is in fact 49. So that was just a quick note to make mention that sometimes we can logic our way to skipping some of the math if we can realize that it's going to produce a value out in the side of it in a one-sided test. If we're getting values that are going to be that far, there's no rejection region over there, right? So 49,000 though is going to be somewhere on the bottom side of this distribution. And so what we need to do is figure out if this is in fact in the rejection region. So we found X bar as 49,000, but remember, we do need to calculate the sample standard deviation. So let's say S came out as 3K. Okay, just for sake of simplicity, we'll go with those numbers. And so now, again, because of all the work we've done in steps 1 through 4, all that's left to do is to calculate the t value. So let's do that quickly. So t is x bar minus mu over s divided by the square root of n. Let's plug in what we know. We found x bar as 49. I'm just going to drop the k here. Not going to, at the end of the day, it's not going to change the end result if I put 3 zeros after everything. So we get 49 minus 52, and then divided by 3 over square root of 25. Okay, so this becomes negative 3 over 3 over 5, which, if I do rearranging correctly, should give me negative 5. So we get a t value of negative 5, which is quite certainly in our rejection region. So we found a value down here. And so we can go ahead and reject the politician's claim that the average income in the community is at least 52,000. Our sample, albeit only 3,000 less, because probably because mostly driven by this small standard deviation, this sample size, or this sample, has produced enough evidence to reject that null. So in reality, the S is, I probably picked a quite small S that I just kind of randomly made up. It's quite possible that the S would be larger than that, right? And so why don't we just finish up by looking at that. If in fact we had said S was 13,000, let's say, something maybe a little more realistic, how would that change our equation? Well, that's going to simply, we would have the same 49 minus 52, but of course when we increase S is our estimate for standard deviation, and so when we increase standard deviation of the population, we're also increasing the standard deviation of that sampling distribution. So we'd be more likely to find a sample mean down near 49,000. So let's see if this would in fact have triggered falling into the rejection region. So all that's changed is we put a 13 down there. And let's see, that's negative 3 over 13 over 5. And so what is that going to be? 15 over 13. Somebody can double check my math, but that's going to be, so still at negative. And so what is that? That's 1.08 076 or something. I'm trying to do that off the top of my head. But what I can tell you is that it is less than the negative 1.711, and so we wouldn't reject the null. Okay, so a more realistic probably S, although again, if this is what the sample produced, that's what we would go with. So I just want to highlight that the S is important here as well. So the X bar is important, but what we get from the sample the sample standard deviation is also heavily factoring into whether or not we think we have enough evidence. And again, S is unlikely to jump around this much. So really what I was doing with the blue is probably putting it more towards something that you would find with when we took samples of people's income. But that's kind of two little looks at this scenario as well. So hopefully these two examples, the chopsticks and this monetary example, help you kind of put in frame what we do in step 5, and again, a lot of our work is done in steps 1 through 4, and then we just simply recrunch the numbers. And you can see, again, not to go on too long, but one of the values here is that notice when, for instance, in this production process, we took a sample on the yellow day here, and it showed up as negative 1.5. We were able to quickly say, oh, that's not in the rejection region. The next day, all of the setup is still there, and we simply take a new sample. And so again, this is why this process is used heavily in production processes, because you can get everything set up to repeatedly take samples every day or every hour, whenever it's necessary to run samples on your production. And all you need to do is quickly calculate a z-score. And in fact, sometimes people take it a step further and put it in terms of just what is the sample mean that you would need, right? So we could fully crunch that as well, and so maybe we'll look at that at another time.